So we've been looking at invertebrate animals. There they are. Now we're going to look at the vertebrates. Vertebrates are within the phylum Chordata. Now, the phylum Chordata includes a couple transitional groups between the invertebrates and the vertebrates. And so the vertebrates are within Chordata, but not all of the phylum Chordata are vertebrates. So this is a subphylum. And the main groups include fishes, amphibians, reptiles, birds, and mammals. The chordates, or in the phylum Chordata, are distinguished by 4 features. A dorsal hollow nerve cord, which contains a bunch of nerve tissue, a stiff notochord, which supports the whole structure, gill slits or pharyngeal slits behind the mouth, and a muscular post-anal tail. Now you may wonder, hey, I'm a vertebrate, but I don't have gill slits or a tail. But we did when we were embryos. And that's the key. Not all of the vertebrates or chordates have these features into their adulthood. Now, the simplest chordates are called tunicates and lancelets. Tunicates here have like a tunic around their neck. Lancelets kind of are lance-shaped, hence the name. Marine invertebrates, typically unobtrusive, hanging out in the bottom of the ocean. Enough said about them. Let's get on to the vertebrates. Most of the chordates are vertebrates. They have endoskeletons like the echinoderms do, but in this case, their skeletons are bone or cartilage, and they include the skull. And because of this, vertebrates are often called craniates. Cranium, skull. And their backbone consists of vertebrae. And you can see the vertebrae here assembled all the way through to make up the backbone, all the way down into the tail of this cat. Most of the vertebrates have hinged jaws. These are gnathostomes, vertebrates with hinged jaws. Lampreys, often called lamprey eels, even though they're not really the same as the American eel, which is a fish, they lack hinged jaws. They have a disc-like jaw. And they're often parasitic. They latch on to fish and feed off of their fluids. These are called the agnathans. Agnathans include lampreys and hagfish, which are some people consider invertebrates. Jaws are important because they support the structure of the mouth for feeding and in fish for their respiration. The gill arches. Speaking of fishes, you have different classes of fish. You have the cartilaginous fish, which include sharks, skates, rays, chimeras. Their skeleton is made of cartilage. The features of these fish are a little bit different too than the bony fish, which we'll look at here in a second. they often have, as sharks anyways, they have a heterocircle tail, and they have the gill slits that are unprotected by anything. Osteichthyes, or the bony fishes, such as this American shad here, have bone instead of cartilage. And you can see that instead of having exposed gill slits, they have this cover called the operculum, gill plate. Bony fishes are much more diverse than the cartilaginous fish. Their fins are more flexible and more mobile. They have that gill plate or operculum that covers the gills. It opens up so that water can get into the gills. And they also have an air bladder, and the air bladder allows them buoyancy. Okay. Air bladders are not a feature of the chondrichthyes or cartilaginous fish. And so they often either are non-buoyant, they hang out typically on the bottom of the ocean, need to swim constantly to keep water moving through their gills, or pump water through their gills. And a lot of sharks have a lot of oil, squalid oil, that allows them to maintain buoyancy. Amphibians were the first vertebrates to come onto land. They are in the class Amphibia. They include froggies, like you see here. It's a poison dart frog. Toxic skin. Toads, which are a little bit more warty and have drier skin. Salamanders, which are elongated and have a big tail as adults. Frogs and toads lack tails except in the juvenile tadpole stage. Because of that, frogs and toads are called anurans. As adults, they lack tails. Then you have these worm-like amphibians that are typically tropical, nocturnal, and below ground fossorial, typically, that are called amphisbaenids. Amphibians were the first terrestrial vertebrates. They came from a class of fish that had lobed fins on the bottom that eventually evolved into feet. And these limbs allowed them to move onto land. But they are still obligated to being near water because their eggs are gelatinous. And because of that, they desiccate if they're not near water. So amphibians lay eggs either in water or at least in moist environments, like some salamanders do if they're terrestrial. Reptiles have more terrestrial adaptations than amphibians. They're able to live on land because they have waterproof scales, a shelled amniotic egg, and the amnion protects the egg from any kind of mechanical shock. And it also prevents dehydration. Modern reptiles are ectotherms, like everything else we've looked at so far. Ectotherms meaning that these are organisms that cannot maintain their own body heat and are therefore at the same temperature of their environment. If they want to get warm, they need to come out and bask. And if they get cold, they need to go hide somewhere to maintain body heat. Now, dinosaurs were considered reptiles for the most part. although they're quite different from our modern reptiles. They were very large. They inhabited land. Big brontosauruses, Tyrannosaurus rex. But they may have been endothermic, unlike our modern reptiles, meaning they could produce their own body heat. In order to be that big and have that big of a core, you need to generate heat, or you will generate heat because of your metabolism. Reptiles, a group of them called the pterosaurs, morphed into creatures that could fly. And they were smaller because it's better to be smaller if you can fly to be able to get off the ground. And in order to keep warm, they developed feathers. Those feathers, though, also were able to allow them to generate lift better so they could get off the ground and fly. Look at how reptilian they are, with scaly skin, claws in the older version, but still in our turtles and lizards and crocodiles, they have claws. Right? The only difference between birds and reptiles are that birds are endothermic, like the dinosaur relatives. Reptiles went off to become ectothermic, with a couple exceptions. So, class Aves birds have scales, amniotic eggs, right? A shelled egg with an amnion inside that protects it from mechanical shock and keeps it moist. And birds also have wings that allow them to fly. Not all birds can fly, though, of course, because even birds that have feathers, like ostrich, kiwi, cassowary, rheas, right, they're flightless birds, but they have big legs that they can use to run and big claws to defend themselves, big feet to kick. But all birds have feathers. They're endothermic and homeothermic, meaning they maintain a stable body temperature. Hollow bones are called pneumatic bones. They're not totally hollow because they have struts that help them with mechanical reinforcement. But hollow is important because that allows them less weight to be able to fly. And a very good circulatory system in order to maintain blood flow to these muscles when you're doing a very active type of movement like flight. Mammals are another branch that came from ancestral reptiles. They're endothermic like birds. In your reading, you'll read about an intermediate type of reptilian mammal thing called a cynodont. Two unique characteristics: hair or fur. Okay, hair and fur are two different things. Hair are more pokey, elongated. Fur is more dense, but it's an insulating material to help maintain body heat. And then, of course, they're called mammals because they have mammary glands. There's a lot of other characteristics, too, of mammals, including 3 middle ear bones and different types of other glands like sebaceous glands or exocrine glands, sweat glands. But hair, fur, mammary glands are the big ones. Most mammals give birth to young after some time inside the mother. And the embryo is, in some mammals, nurtured by an organ called the placenta, but not all mammals. A few mammals lay eggs, like the monotremes. The monotremes include the duck-billed platypus that we see there. and also the spiny echidna. Marsupials now are another type of mammal. And their young are born very underdeveloped. And the young crawl to a pouch, typically in the female. And there they latch on to a nipple where they feed and finish their development. And sometimes even after they're developed relatively well, they still hang out in the mother's pouch, like a kangaroo. In North America, we only have one marsupial, and that's our friend, the Virginia possum. Placental mammals are called eutherian mammals, and they have a long pregnancy or gestation period. In humans, it's 9 months. In elephants, it's 22. In some small rodents, it's only a month. But the young are born more developed because most of the development occurs within the mother in the uterus, fed by this apparatus, if you want to call it, or suborgan called the placenta. And so there's our review of all of the animal diversity, including all of the invertebrates that we looked at. And you can look at this phylogenetic tree and see where things split off. True tissues, not true tissues. Radial symmetry, bilateral. Okay. Body cavity, no body cavity. True coelom, not a true coelom. Where the first tract occurred, whether it was the anal tract or the mouth tract, branching off the echinoderms because they went off to radial symmetry again, and then to the chordates. I didn't really notice that wolf was behind me the whole time. Not stalking me, I hope. I don't know. Not glaring at me. Oh no, he's going closer.